Hi, today we're going to discuss about this paper called Control Prefixes for Text Generation. So the idea behind this paper is to extend prefix tuning to also dynamic prompts. So because most of the current work they rely on shared dataset prompts for all examples, and they want to extend this approach to dynamic method, which allows for the inclusion of conditional input dependent prompts, input dependent information in each prompt. So in prefix tuning, all of the examples have they share the prompt, and here they want to change the prompt based on the input. So it's this work considers dynamic prompting. So let's directly go to the method. So this is prefix tuning. This is control prefix. So prefix tuning is we append a prefix to the input. These 5 are the inputs, 1, 2, 3, 4, 5. And for each input, there is a prefix tuning, which is actually shared by all of the examples. So this is mostly task specific. So for each task, there will be a prefix, which is trained on that specific task. The language model is frozen. So this is the setting for prefix tuning. For control prefixes, this part remains the same. So these are again the inputs, and this part is the prefix tuning. But for each input, there is some guidance which gonna categorize each input into some category. So 1 and 4 belongs to one category, 2 and 5 belongs to another one, and third is 3 is another one. So for each category, there is a control prefix which is gonna get attached here. So this pink is gonna attach here, and likewise for other examples. So what's happening here is the idea here is there is some input, and for every input there is some there's some information about it which is used to categorize it into different types, and for each type there is a prefix. So the whole idea is that the whole idea is to leverage natural language understanding from the pre-trained model. So that's why it's kept frozen, to have task specific information through this prefix tuning, and input specific information through this control prefixes. So now let's go to the data set and experiment. So here they are using 3 tasks. Data to text. Data to text is given there is some structured input. It has to create some fluent text. Okay, so they get a triple set of subject, predicate, and object, and the model has to create a fluent text. Simplification is the model has to simplify the sentence, and summarization task we all know. Data to text, there are 3 data sets which they use: Dart, WebNLG, and E2E. And for simplification, they use they train it on Wikilarge and evaluate on the corpus and assets. And for summarization, they test the report the results on XSum dataset. So the key important part here is the attribute which they use for each dataset. The attributes. So the key part is the guidance which they use to categorize the input. So for data to text, they use categories from this DPpedia. So there are categories like airport, food. So if the input has the domain airport, is gonna be assigned a prefix. If it is like food, is gonna be assigned a different prefix. So similarly, there are different categories. For simplification, it's a little different. For summarization, for the data to text and summarization, they use attributes, but for simplification, they use another kind of prefix, a control prefix called control ratios. So this is the sequence length of the target sequence divided by length of the source sequence, and they are divided into bins from 0 to 2 with this much width, fixed width. So what they do is they have these control tokens that are then included in the vocabulary. So they're like 40 tokens. If you calculate here, there will be like 40 tokens. So the idea is that depending upon the ratio, control ratio, the inputs are different. Like they are input depending on the control ratio. The prefixes, control prefixes appended to the input. So what happens at the inference time? Because so once the model has been trained with these oracle control, the control ratios are set to desired value by tuning on the respective validation set. So they somehow they actually fix it. They are set to some desired value depending on how the model is tuned on the validation set. So let's go to the result. So this is for data to text task, and they are experimenting it on Dart, WebNLG, and E2E Clean. So this is T5 large fine-tuned on these data sets. This is state-of-the-art method, the state-of-the-art result. This is just prefix tuning. This is control prefix with just A1, which is attributes from WebNLG. This is prefix tuning. So they also included the Dart dataset here, and this is the control prefix for A2. This is from Dart attributes, and then control prefixes from these two. So what they are claiming is that it performs state-of-the-art results for each dataset. And it is a little like it increased, like kind of 1.5 here. So it's not a lot, but it did improve for control prefixes. For simplification, they used BART large for asset and corpus, and for prefix control prefix, they have some not good. I mean, it's not like it doesn't perform very well on simplification tasks, and yeah. So for summarization task, it does performs better. Again, there is not a very large improvement, but it's better. So they also tried visualizing control prefixes. So what they are doing here is they are plotting. This is for simplification tasks, and they are plotting the control ratios. So what exactly they are plotting here is, this is the TSNE visualization for the decoder self-attention constituent of the length compression control prefix of the simplification task. So this is the decoder self-attention constituent of this control prefix, and if you plot it, you're gonna get there's some pattern in it. It's like 0 compression ratio, and here it is 1.1, and this like kind of a it's like a kind of parabola. So there's some pattern which they plotted, and then what they're trying to they have another experiment where Suppose we have attributes. We know the attributes during training, but we don't know the attributes during test, right? So there may be some attributes, there may be inputs which may belong to some other attributes, and we don't have them, right? So the one way is we can find, what we can do is, for each we can map each category using glove embedding, and then we can find the closest one. Then for each unseen category, we map to the seen category with the highest cosine similarity in embedding space and use the control prefix at inference for the corresponding unseen example. For example, if the control prefix for seen category sports team is used for examples relating to the unseen category athlete. So it's like transfer of the prompts, okay? The other way is that you have a category called out of vocabulary, and you just use that, okay? And what they found is that if you directly use the transfer of prompts, that's like a better that's better than the out of vocabulary representation. So yeah, so finally what they demonstrate is the control prefixes outperforms prefix tuning as well as existing approaches on an array of natural language generation tasks. So yeah, so that's all about this paper. For more information, you can go into details. So thank you.